Well, unfortunately, I am remaking this video because the first video that I made with these examples, I accidentally deleted when I tried to rename it. So we are moving now away from solving equations and inequalities and absolute value into the world of factoring. And we're going to be looking at a number of factoring techniques. The first that we're going to be looking at is what we call the greatest common factor, or a way that we often just shortcut it is GCF, greatest common factor of a polynomial. So the approach we're going to take is first we have to figure out what the greatest common factor is. Next, we're going to do a division where we're actually going to pull out or divide out the greatest common factor from the terms of our polynomial. And then lastly, we rewrite our answer, which is going to be the product of the GCF and what we have left after the division. So in other words, our answer is going to look like a distribution multiplication problem. So the answer to greatest common factor is going to look like distribution multiplication. The GCF is going to be sitting outside the parentheses, and what we have after we do the division is going to be sitting inside the parentheses. Looking at our first example here, we have 20x squared and 30x. Some of you, so back up a minute. The greatest common factor, we're going to be considering the greatest common factor in the coefficients or the big numbers sitting in front of any variables. And then we're also going to be looking at the variables. Looking at our 20 and 30, some of you might see that it would be 10. This finding the greatest common factor is going to be very much a function of your comfort and your knowledge of your basic multiplication facts. So some of you might see these easier than others. If you don't see that, a technique you can use that you can always use to find your greatest common factor would be to take your coefficients and factor them down into their primes. So 20 we could factor as 2 times 10, and then 10 is 2 times 5. So the factors of 20, I'll write them out in a line, would be 2 times 2 times 5. Now looking at 30, well, 30 is 5 times 6. I mean, you could say 2 times 15 also. It doesn't matter where you start. You'll always get to the same place. 5 is prime, but 6 could be factored as 2 times 3. So now writing all my factors of 30 down, and I'm just going to write them in order, smallest to biggest. We have our 5, our 2, and our 3, and I just wrote them as 2 times 3 times 5. Looking at the list of factors, what's in common? We have a 2 and a 2. We have another 2 here, but not here, so can't use it. We have a 5 here and a 5 here. So 2 times 5 are our factors in common. And remember, factors are things we multiply. So 2 times 5 is 10. So there is our greatest common factor, the 10 that some of you might have seen right away. So there's the 10. Now let's look at the variables. We have x squared and x. So let's consider x squared is x times x, and x is just x times 1. I'm not going to bother to write the 1. So what we can see here is we have an x in common. So our greatest common factor in terms of the variables would be x. Something I want to point out here. When we're looking at the greatest common factor for variables, it's always going to be the version of the variable with the smallest exponent. Sometimes students hear greatest and they get hung up on this greatest in the common factor. So they say, hey, x squared is bigger than, it's greater than x, so I'm going to use that. No. It's what's in common here. It's the biggest thing in common. So we can only use as much as the smallest exponent, which might seem contradictory to this, but it's not. So when you look at your variables, when you have the same variable, it's going to be the version of the variable with the smallest exponent. So our answer to this is going to be, as I said, a distribution multiplication. So we're going to have our 10x on the outside of our parentheses and then parentheses with something inside. Some of you might be able to do the division of the 10x from each of these terms. You might be able to do it in your head, 20x squared divided by 10x, and go right here to your answer in the parentheses. Others might need to see the division, so I'm going to do that for those of you that need it. So I take my original polynomial, 20x squared plus 30x, and now I divide it by the greatest common factor, 10x and 10x. 20 divided by 10 is 2. X squared divided by x is x. Remember, when we divide, we subtract exponents. 2 minus this invisible 1 that I'll write in, 2 minus 1 is 1. Moving to the next term, 30 divided by 10 is 3. And now x divided by x is just 1. So there is no x here because these x's cancel, is another way to think about it. So here's our answer. As I said, it looks like a distribution multiplication problem, and indeed we could do this distribution multiplication to check that we have the right answer. Next one, we have 9 and 21. 9 is 3 times 3. 21 is 3 times 7. So the factor in common, and there's only one, is going to be the 3. Looking at our variables now, we have x to the 4 and x squared. So we're going to be able to factor out x's, and we're going to be able to factor out x squared. So there is our greatest common factor. Again, our answer is going to look like this distribution multiplication that I've written here, at least the beginning of it, with the GCF on the outside. Now for the division. 9x to the 4 plus 21x squared. And I will write my greatest common factor in the denominator to show the division clearly. 9 divided by 3 is 3. X to the 4 divided by x squared. 4 minus 2 is x squared. 21 divided by 3 is 7. And now x squared divided by x squared is just 1. These cancel. There's no x's there. And this would be our answer.